Hello, everyone. I'm Dr. Afshina. Professional algorithm methods refer to the systematic approach used by professionals in the fields of computer science, mathematics, engineering, and other related fields to design and analyze algorithms. Algorithms are a set of instructions or rules that are used to solve a particular problem or perform a specific task. Professional algorithm methods involves several stages including problem definition, algorithm design, implementation, and analysis. The first step is to clearly define the problems that need to be solved. This involves understanding the input and output requirement, the constraint, and the special considerations. Once the problem has been defined, the next step is to design the algorithm. This involves identifying the steps needed to solve the problem and organizing them in a logical sequence. The algorithm should be efficient, accurate, and easy to understand and implement. After the algorithm has been designed, it needs to be implemented in the programming language. This involves writing code that translates the algorithm into executable instructions that the computer can follow. Finally, the algorithm needs to be analyzed to ensure that it's correct and efficient. This involves testing the algorithm using various input and analyzing its performance in terms of time and space complexity. The goal is to ensure that the algorithm is scalable and can handle large input without slowing down. Professional algorithm methods are essential in many industries.
Open eye, feel the waves cut through me, hypnotized by the sounds I'm breathing in. Hold tight, chemicals collide. Hold tight, hold tight, hold tight. Dripping lights paint the skies, all because of you. Dripping lights paint the skies. Only you can make me. So alive, make it last forever. Stop in time, yeah, I'm surrendering. Hold tight, chemicals collide. Hold tight, hold tight, hold tight. Dripping lights paint the skies, all because of you. Dripping lights paint the skies. Only you can make me so alive.
including finance, healthcare, and technology. They help organizations solve complex problems and make the data-driven decision. You can write a professional algorithm using OpenSees. OpenSees, Open System for Earthquake Engineering Simulation, is an open source software framework for simulating the performance of structural and geotechnical systems subjected to earthquake or other hazards. It provides a scripting interface that allows users to create and customize their own analysis algorithms. To write a professional algorithm using OpenSys, you will need to have a solid understanding of the underlying mechanics and mathematics of structural analysis. You will also need to have experience using OpenSys and be familiar with its scripting language. The process of writing a professional algorithm using OpenSys would typically involve the following steps: define the problem that needs to be solved, including the input and output requirement, the constraint, and any special considerations. Design the algorithm using the scripting language provided by OpenSys. This involves identifying the steps needed to solve the problem and organizing them in a logical sequence. Implement the algorithm by writing code in the OpenSys scripting language. This involves translating the algorithm into executable instruction that OpenSys can follow. Test the algorithm using various inputs and analyze its performance in terms of time and space complexity. This will help ensure that the algorithm is correct and efficient. Overall, writing a professional algorithm using OpenSys can be a complex and challenging task, but it's certainly possible for experienced users who have a strong background in structural analysis and programming. Now I would like to show you a more complex example that use neural network method in OpenSea to predict the performance of a simple 2D frame subjected to earthquake ground motions. The algorithm uses various OpenSea commands to define the model geometry, material properties, boundary conditions, and loads. It then defines the neural network architecture and trains it using a set of training data. The algorithm also defines the earthquake ground motion and analysis procedure that uses the trained neural network to predict the frame's response. This is just a simple example, and in practice, more complex neural network architectures can be used to predict the response of more complex structures under various loading conditions. Additionally, the training data can be generated using various techniques such as Monte Carlo simulation or experimental testing to ensure the neural network is accurate and robust.